Okay, in our previous segment, we were talking about the Big Bang and how the universe expanded and how the first atoms consisted of hydrogen and helium. So let's talk about that for a moment. Hydrogen consists of one proton and then it's got one electron in orbit around it. So that's hydrogen, the most common isotope of hydrogen. The most common isotope of helium consists of two protons, and then it also has two neutrons, and then it's surrounded by two electrons in orbit. And we said that this, about 75% hydrogen was formed after the Big Bang, and roughly 25% helium formed. So the question is, where did the other elements in the periodic table come from? So oxygen, nitrogen, iron, lead, any of those other elements in the periodic table, where did they come from? Well, they came from stars. So we said that after the Big Bang, there were these gigantic clouds of hydrogen and helium. And so because of gravity, they started to collapse, and as they're collapsing, their temperature goes up. So as they expand, if something expands, its temperature goes down. If something contracts, its temperature has to go up. So as these clouds began to collapse, their temperature, if the temperature could get to 10 million Kelvin, then what can happen is that hydrogen slams into hydrogen and it fuses into helium. So this is called nuclear fusion. And all stars that are living are converting hydrogen into helium in their cores. Now the question though is, what happens when stars begin to run out of hydrogen? So let's take, for example, a very small star. A very small star can only make helium because it doesn't have enough mass to cause enough gravity to get to a high enough temperature to fuse helium into something else. They just don't have enough mass to be able to do that. So that these stars are just going to cool off and turn into cinders, and we're just going to call these things black dwarfs. Okay, but now let's take a look at a star that is bigger than one of these little guys, like our sun. Our sun, in about 5 billion years, is going to start to run out of hydrogen. When it runs out of hydrogen, then the nuclear explosions begin to die down. Now, those nuclear explosions were what was pushing outwards to keep gravity at bay. So gravity is going to start to squeeze the core of our sun, and the temperature is going to start to go up. If the temperature can get to 100 million Kelvin, then heliums can be smashed together and they start to turn into the element carbon in the periodic table. And then another thing that happens is that the outer layers of the sun expand. So the core contracts and heats up and begins to manufacture carbon, but the outer part of our sun expands, and we're going to call that a red giant. And we think that when our sun becomes a red giant, it will come at the edge of the sun will be about at the orbit of the Earth itself. So the sun will be very, very large when that happens. Now, eventually, our sun is going to start to run out of helium. And when it does that, then the core is going to collapse again. The temperature is going to go up. Okay, but this time the temperature would need to get to 500 million Kelvin before the next element could be forged. And so our sun will not be able to do that. So then what will happen is the core will collapse and will eventually cool off and will eventually become another one of those black dwarf things. The outer part of our sun, the red giant part, will just be jettisoned into outer space as a planetary nebula. So notice that this is a way of taking the elements that are forged inside of a star and then scattering them into outer space. But if you have a larger star than ours, the next thing that it can start to manufacture is going to be silicon.